Hello friends! In this lesson we will save the game progress to the local storage. First, let's save selected game properties when we start a new game. Move to the new game handler and save props we have. Local storage, width, height, and bumps. And we need to reload them after refreshing the page. To do this, let's use immediately invoked function expression. Write an arrow function and call it. In this function we need to read all our variables. If there is no variable, use the previous value. Check how it works. Okay, now we save the main properties of the game field. Let's move on. We need to add a function to save our game field. Just save field data as is. It will be converted to comma-separated string. And we also need to save the states of the field cells. Call it field states. Save field visualization variable here. Maps through the rows. And the cells. We need to save the state of each cell, so let's check whether it opened or not. Find the state if it is closed. And I want to add one more field to the state, because I don't want to save long values. Call it short, or if the cell is opened. Okay, let's add this short field to the states. S for standard, P for protected, and question mark for question. Now we need to call our save function. Add the new game function. After changing the state, and we also need to call it when we open the cell. But we need to do it conditionally. So let's add one more argument first. And save data if it is true. And I forgot to do it before. Let's get neighbor's bomb count from the field data, because we already have it. We don't need this cycle anymore. Okay, add true here. And we also need to save the game here. Okay, all should be saved now. Let's add two more functions. First, for the clearing the local storage data. Just remove saved data here. And one more to load the data. Initialize the bomb counter first. Read the field data from local storage to the variable. Split it by the comma. Map over the array. We need to convert the string data to the number first. Increase the bomb counter if it is the bomb. And return the value. Read the field states to a variable as well. Split it. And we need to convert our short variable to the states. We need a function to do this. We will implement it later. Okay, we need to check if our data is correct. We need to check if both variables are exist. They should be the same length. The length should be equal to the game field size. And bombs count should be also correct. Set is running to true. Fill data to an empty array. Now we need to convert readed states to two-dimensional array. Add a variable first. Add a while loop with data length condition. And fill both our arrays. Push the part of the readed array to new array by using the splice function. It cuts the data from the array and returns it. And the same for the second array. Call the field visualization function and provide the states there. Invoke the game start event to start the game. We need to update the states variable. Let's add a function for this. We will implement it in a minute. And we also need to invoke change state event after it. Return true if everything okay. And if our condition is false, we need to clear the local storage data and return false at the end, inside or outside else condition. Okay, let's add findState function. Iterate over the object. And return the state if you found it. Return shot otherwise. And add update current states function. Set current states to an empty object. Iterate over the field visualization rows. And also the cells. Get the state of each cell. And increase the amount of the state in the states object. Zero by default. Now we need to provide the states to the field visualization function. First, move the closed cell counter from here to here. Now we need to check if states are provided and do something in this case. Otherwise, all should work as before. Copy it here and provide the states. And we also need to calculate the count of the opened cells. Let's use a reduce function for this. Total to store the count and iterate over the rows. Initial value should be 0. Set it to total plus the reduced row. Compare the value with O and increase the amount if they are equal. Subtract the opened amount from the closed counter. Move to the create row function and add states to it. Check if states exists as we did before. If the states are exist, provide the self state to the create cell function. Copy and provide. Next, create cell function. State. We don't need the closed class here, and we don't need to set the default state. Set the inner HTML to the state HTML property. If the state was not provided, use the default. And the empty string if the state not found. Check the state. Set closed and default state if it wasn't provided. Otherwise, check if it is opened. In this case, we need to set the state to default. And in HTML to the number span or empty string, as we did at the openCell function. Okay, now we need to edit our new game over and reset functions. First, we need to return if there is no field data. And clear the saved data. In the new game function, we need one more attribute, call it clear. We need to fill our field only if the clear attribute is true, or if load data function returns false. Because of lazy evaluation, load data will be called only if the clear is false, or falseable as well. We also need to clear the game data in the game over function. At last, we need to update the calling of the new game function. We need to provide true here. And false here. Let's check it. Okay, we can also store a timer, but you can do it by yourself if you want. And our game is definitely done. We can stop here. Like, subscribe, and watch my other videos.